Hi, I am Pedro Sodré, the manager of Mage Group, and I'm here to show you the Deliverable 4. So let's start with our schedule. So we planned to work 55 hours plus 17 that we are delayed. So that becomes 72 hours. We worked 56. We are still delayed from the deliverables 4 and before 4. 17 hours, but we advanced from the level 5 hours, so the balance is 12 hours delayed. We could catch up a little, but we're still delayed. We're still a little bad. So I will show you like the structure working. Let's start from the beginning. Here we are like putting candies into the machine. Of course, will be more candies, but here are we are closing. Here are the candies fall down into the cups. And then the cups will reject the candies after some time, right here. So, and after this, we have like this structure. Let me start from the beginning. The same thing. So, start fall down the candies into the cup, and then the cup will turn to accept the candies. So it will go through this pot right here. So the machine is going fine. The second tube, the Archimedes screw, broken up, but we are like creating a new version of the two Archimedes screw to don't break up the screw, and we are like running through this. That's one of the causes that we are delayed. So our second Archimedes screw wasn't working properly, so we are making two new ones with a new version, a better version of the two. Uh, we will like change the material too to make more resistant, and then everything is going to be. We think everything is going to be good, like in this new Archimedes screw version. Uh, Here we have the app screens. So the main screens, the edit payment keys, where the owner will set up his Pix key, change password, and login screen. Also, we have the code right here into the into GitHub. We have a lot of things working, but we don't have time to show you to record a video to show this. But Thursday we will show everything like working fine. So we have like the display, the gesture recognizer where I recognize the hands. Uh, we have the machine where we'll move the servo motors. And we have a lot of like the payment measure where there are the Pix key. And all of this like is implementing the software. I will pass to João to explain more about the firmware, so it will be more clear.
So about our firmware, a quick rundown of how it runs. The Raspberry Pi starts with this booting phase, where it syncs all the relevant data with Firebase database, and then it enters these various phases that control the operations of the machine. To demonstrate how the booting phase works, it connects to the database, it updates the information, and if the system was in payment when it was shut down, like in an energy failure, it delivers the candy and if not, it just rejects any candy that may be on the cups. Demonstration of the update. Right now, locally, the price for the second candy is at 4, as it is in the database. If we update here to 7, and it has updated, we'll see that when the program starts, it will automatically update this value. So you can see it got the correct information from Firebase. Here it delivered the candy because when the program was last closed, it was in the payment phase, and it started the second thread to listen for notifications. So we can see that the buffer was updated in the editor, and now the local price is matching the database. Continuing, after the boot phase, the program will go to the introduction phase, where it will search for the payment key. Here there is a dummy payment key already, so it continues to instructing the customer how to start. Ask for the stop sign, where it will wait until it is done. Here it is a dummy stop sign just to demonstrate. So you need to hold the stop sign so that the machine detects that there's a customer. So after that, the customer is detected, so it goes to the confirmation phase to confirm that there is a customer. So here's the message saying that a customer was detected. And now it will read the camera for a thumbs up. Or if it loses track of the hand, it will go back to the introduction phase. Like in this case, the none sign means that the camera is not detecting anything, not a hand, nothing. So we can see that here it went back to the introduction phase, and it's asking again for a stop sign. So if we hold the stop sign, it is again in the confirmation phase. So, and if we show a thumbs up, it now asks for it now went to the selection phase, where it is asking for the candy type. There are many gestures possible here. So for starter, if it detects a hand but no gesture, that it's what we call a undefined gesture. It will use this position to update which candy is selected. In this case, it is hard-coded to pick the first candy, but with the camera it can detect the position in relation to the size of the camera. So now the first candy was selected, and we are back here to read the camera. If we do a thumbs up, we confirm that it's this type of candy that we want. If we do a thumbs down, it means we are canceling the purchase, any purchase we may have done. And if it loses track, it also cancels the purchase and goes back to the introduction phase. So if it loses sign of the hand with a non-signal, it will give a message, and if it still doesn't find the hand, it will, here it is rejecting the candy, and it went back to the introduction phase. So if we do the steps again, we hold a stop sign, we do a thumbs up to confirm we want to buy candies, and we select a candy type. We could now we could now, for example, buy candy by selecting with the thumbs up that we want the candy that was selected. So now we enter the pouring phase, where there are 3 possible gestures. There is the fist, where it will to pour the candy, thumbs down to cancel the purchase, like always, and stop to stop pouring candy and go into the decision phase. So we can, it also has some checks, like if the cup will overflow and if there's candy left, in the case of the fist. So for example, we are holding the fist, we can see that the DC motor is activated and that the candy is updated. In this case it is slow because like each of these calls represents a frame, so in the real world with the Raspberry it will be much faster. But here we triggered this failsafe, which stops the DC motor. You can see the DC motor is turned off and it will not turn on again, even if you continue to make the sign, because we do not have enough candy in storage. And so if we ask a stop gesture, we will buy what we already chose. Now we went to the decision phase, where we can make the final decision if we want to buy or not. So we have 3 possible options, plus the case that the customer is undetected, where we will cancel. So the 3 possible options is the thumbs down to cancel the purchase, thumbs up to go to payment, or the peace gesture to return to choose more candies. For example, we can use the peace gesture to return. So now we are again at the candy type. Since we already chose all the candies, there is no, it asks for us to choose another type. So in this case we could cancel the purchase, like we could here. So you can see that we canceled the purchase and the servo rejected any candy that we had poured in the cup. And this is the payment phase is implemented, but this support type here is lacking the payment keys, so it's not possible to demonstrate.